This presentation will cover Facebook and its big data. The presentation was completed by Devin Keebler, Peter Knowles, Mark Gentile, and Kevin Vogel. To start with a quote from Facebook's head of analytics, Facebook cannot be Facebook without big data technologies. Most people think of Facebook only as a social media site, but there is much more behind your personal profile. There are billions and billions of pieces of data being collected from their over 1.3 billion active users. The big question now is, how is Facebook going to cope with the massive amount of growing data? In the company's initial years of operation, Facebook used open source databases such as MySQL. MySQL was good for some workloads, such as user profiles or lists of friends, but not for data-intensive workloads. As the former technical lead, Kannan Muthukurupan, explains, everything was bursting at the seams in 2007. When Facebook's user growth exploded around 2007, Facebook needed solutions. Facebook's data storing issues began to start looking upwards with the use of Hadoop. Hadoop is a free Java framework for distributed applications and intensive data management. It enables applications to work with thousands of nodes and petabytes of data. Facebook now maintains the world's largest Hadoop cluster in the world, spanning more than 4,000 machines and holding hundreds to millions of gigabytes. Facebook uses Hadoop in 3 different ways: as a data warehouse for analytics, to store their distributed data, and to back up their MySQL database servers. Hadoop's main advantage is its performance with scalability. Facebook was now able to use their current hardware, begin to establish a more distributed database system, work with data of many different structures, and create backups to restrict the consequences of database failure. However, even with Hadoop, the social media company found itself constantly buying new servers due to their lack of storage space for photos, which the company currently was using a network-attached storage system for. The solution ultimately led Facebook to make continuous large capital expenditures in IT, and in turn began their search for other database types that could handle their exponential growth and scalability of users and data types. With this came along HBase, another open source distributed database that could scale up to petabytes as well. Kannan Muthukurupan, who was the lead behind the company's consideration for applying HBase to their database structure, said, "The challenge Facebook had was to design an infrastructure out of simple building blocks that you don't have to throw away every 2 years. With much larger data storage capabilities, Facebook can now store more information of users and begin to connect them in different ways." Furthermore, Facebook was able to introduce Facebook messaging for the first time, and this was the first application which used HBase in 2010. This gave the company the data storage and analytic abilities that allowed them to get one step closer to attaining Mark Zuckerberg's ultimate goal, to unify all mediums of communication into a single product. With a large infrastructure of servers in place, Facebook decided to end their major investments in infrastructure and look for new ways to expand their data storage. The solution to this problem was Prism. Prism allows data clusters to be managed in a more logical way and communicate with servers in other locations. This allowed Facebook to use the servers they already had in a more effective way. They are also working on other types of software to maximize and expand the use of Hadoop. Facebook has yet to share this software with the public, but it seems like a likely event in the near future. Facebook today is able to do much more than just store users, their photos, and their chat messages. One of their most recent breakthroughs that has come as a result of their scalability and ability to connect users in ways you could never imagine is their new application, Graph Search. Graph Search is a semantic search engine used on Facebook. This feature combines the big data acquired from its over 1 billion users and external data into a search engine, providing user-specific search results. Graph Search is similar to the traditional search engines that we use today, such as Google. However, the difference is that it is designed to match phrases and objects as opposed to feeding you back results based on matching keywords. Graph Search allows you to search people, places, pages, objects, posts, and comments of others. Not only can you search these types of data that can connect users, but you can also search the web directly from the Facebook search bar. Another feature is that the results a user gets back are filterable, such as giving you a certain time frame. Facebook is promoting to unlearn the model of using, for example, the 3 vaguest words possible, and instead wanting people to say actually and exactly what they want to say or know.
Created using Powtoon.